So today's warm-up, we're going to be continuing working on writing expressions, substituting in for the variables, and simplifying those expressions. So today we're going to continue working on writing expressions, substituting in for the variables, and simplifying those expressions. So here we are. Today's warm-up is talking about some of our classmates riding bikes. Oops. And we are going to be writing expressions and then substituting in. Each one of these, of course, has been a little bit different from the rest. This one, again, is different, an extension of what we started yesterday. So we've got Justin rode his bike 2.2 miles farther than Matt after school. So we know the first thing we don't know is how far Matt went. So that's going to be our first let statement. Let M equal distance Matt rode his bike. Now I have noticed that on some of your warm-ups you're not being specific enough. It's very, very important that in these descriptions we're as descriptive as possible. So it's not just a distance. We can't say let M equal Matt. That doesn't make any sense. Let M equal the distance Matt rode his bike. Okay? And we can't leave this first bullet here yet because we haven't talked about Justin. Justin rode his bike 2.2 miles farther than Matt. So farther means I'm going to add. So I'm going to have let M plus 2.2 equal distance Justin rode his bike. Next person we have is Allison. She rode her bike 2 miles less than Justin. So here we are. We've got Justin. Okay, my dogs are barking. That's annoying. Sorry about that. Justin rode his bike M plus 2.2 miles. So I know that Allison rode 2 miles less than that. That means I need to subtract from this. So I could have M plus 2.2 minus 2. And I can leave it like that. That is correct. Or I can change it, and which I would advise you that you do, because it'll make things a little bit cleaner, a little bit nicer to look at, is I can take this and notice that 2.2 minus 2 can be combined. We can put that together. So 2.2 take away 2. Well, don't forget that's really 2.0. I've got 2.2 miles. Take away 2 of those miles. I'm left with 0.2. So really it's M plus 0.2 equals, and don't forget I still have my let statement, let M plus 0.2 equal distance Allison rode her bike. Now, I just want to repeat, you can use this. This expression here is correct. Or you can use this one. Either one. Like I said, my advice is to use the one that's more concise. It'll help us later when we are doing things with these expressions, but either one is correct. And the next one I have is Jackie rode her bike twice. We know that means 2 times. Twice as far as Allison. So Allison was our last let statement. And you can see it immediately why I want to use this shorter expression right here. I'm going to be doubling that. Now, because I'm doubling this whole entire thing, it belongs in parentheses. So I'm going to have let 2 times the quantity of M plus 0.2. Now, it's very important that you use those parentheses because this whole entire thing gets done first, and that whole entire thing gets doubled. And that, of course, is equal to the distance that Jackie rode her bike. So here we are. We've got 4 expressions. We've got M for how far Matt rode his bike. We've got M plus 2.2 for how far Justin rode his bike. Again, you can use either one of these, but I'm going to focus on the one that's more concise, more efficient. M plus 0.2 for Allison, and then 2 times the quantity of M plus 0.2 for how far Jackie rode. Okay, so along here, we now have to substitute in for each of those expressions. So I'm going to set up my chart. Some of you are still not setting up this chart. So please, please do yourself a favor. Make things easier for yourself and set up these charts. First I have Matt. Then I have Justin. Next I have Allison. And finally I have Jackie. That is an A. Sorry, Jackie. Let's see if I can actually fix that for you. Oh, that looks much better. So Matt, I know my expression is M. Justin, we've got M plus 2.2. Allison is M plus 0.2. And Jackie is 2 times the quantity of M plus 0.2. I know up here the information that's given is that Matt rode his bike 1.6 miles. So for each and every one of these, I have to say that M is equal to 1.6. M equals 1.6. M equals 1.6. M equals 1.6. Oh, I'm moving off the page here. Let's see what I can do about that. Slide that whole little thing over, because you do want to see it all together, I'm sure. Let me fix this. Whoops. I don't know why it's not letting me erase right now. Let's see what I can do here. Well, I'm just going to cross it out. And right just above it, M equals 1.6. So sorry about that. So now, very simply, I'm going to substitute in and solve. I know that this substitutes in very simply. It's 1.6 miles. MI is the abbreviation for miles. 1.6 plus 2.2. I know I'm going to add, I know that when I'm going to come down here and stack my decimals on top of each other, just so that you can see it. Oh, that is a 2. So bring my decimal straight down. 6 and 2 is 8. 1 and 2 is 3. That, of course, is 3.8 miles. Allison, I've got 1.6 plus 0.2. That's an easy one. I know that's going to be 1.8 miles. And then finally, I've got 2 times the quantity of 1.6 plus 0.2. I know I have to do the parentheses first. 2 times the quantity of 1.8. If I double that, I double my 1. 2 times 1 is going to give me 2, so that's 2 miles. Got 0.8 miles, that's 1.6. So I'm going to have a total of 3.6 miles. And here are the distances for all 4 of our classmates.